Welcome to this section entitled Flight Controls. This is part of the 40-hour General Familiarization video instruction course produced by Operation Aviation on the Boeing 737-700. Copyright June 2015. My name is Anastasia Alidan.
I'm Rick Poe.
And we will be your instructors throughout the course of this section. Please keep in mind that this is for instructional training purposes only, and it is not intended to be a substitute for the actual aircraft maintenance manual produced by the manufacturer of the aircraft. Also, you are attesting and acknowledging that you are the one who purchased this section or our module or general familiarization course, and that you will be the one taking the test for this section. So, what can you expect on this whole thing on flight controls? There's a lot of different moving parts, so to speak. I mean, literally and figuratively, a lot of moving parts with this entire section of flight controls. And what's one of the things that you're gonna share here, Rick?
Yes, thanks. And
by the way, I don't need to, what do you do for a living? I don't want to.
Well, I was going to introduce myself. My name is Rick Poe, and I'm a certified flight instructor as well as a commercial airline pilot for over 30 years. With that said, in answering the question, Anastasia, we're going to talk for flight controls today. And with the flight controls today, we're going to have some axes to work around. And essentially, I have a little model here to help me.
We're going in flight.
And so, give you a perspective here. We have roll. That is one of the axes. And then we have pitch, which is the up and down. And then we have yaw. And we're going to go to in each of these phases and discuss how they affect. And essentially, like driving a car down the road, you have an input. And that input affects a certain control surfaces. And we have primary and secondary control surfaces. So with that said, Anastasia, we are going to look at that in depth, but that's kind of like the overview right now on the specifics of flight controls.
Okay, great. All right, and like I said, we have a whole lot of different things to talk about today. The flight controls, obviously the components that are related to all of that and being able to control the plane. And then we also have, just when we're going to get more into details of the field and centering unit, we've got the cables, obviously. And just keep in mind that the 737 does still operate mechanically, as far as its initial input from the control column in the flight compartment. So we'll get into that as well. But this is kind of broken up. The way we're going to do this is we have part one, which will kind of start with the tail of the plane. So we'll start at the tail end of it, and we'll get into elevators, your tab controls, and your horizontal stabilizer. And then we'll also then kind of work our way, towards the front of the plane, or going that direction. So we'll cover the rudders, the rudder and the vertical stabilizer, and the rudder trim control as well. We got to mention the trimming, of that performance.
Right, and with those trims, we also have specific aerodynamic features, which I will discuss when we get into those specific as well.
Okay, good. Yeah, so we're going to have that, and then, as we continue moving our way on the plane from the back, we'll come to ailerons. So now we got the ailerons, what we'll be going into a little bit detail on, which are, actually on the wings, right? You got your ailerons and also your spoilers. And we'll discuss the two different kinds of spoilers, okay, and what they're for. We got different commands going into those spoilers. And Rick will be able, you'll be able to share more the command that a pilot has with that, right?
Absolutely.
Okay.
And, anyway, and then also we have our high lift devices too, which are the secondary, and get into that. And since we're talking about that is for increased performance to enhance, and that's a secondary with the leading edge and trailing edge flaps and slats.
Right. Okay. Yeah. So that will be pretty much what we'll be covering, and you'll be learning quite a bit. And so we'll cover some things that are pretty common, across the board, so that we're not really having to repeat ourselves, and it just makes it easier for you guys to really understand. So let's go ahead and get started with this. Of course, I'm sure you've done Gen Fams before. Maybe you have, maybe you haven't. But there's always, a human factors story that we bring in class. And we're here. An example would be United Airlines Flight 232, when the plane lost flight controls.
Right.
Did you want to share a little bit on that?
Just a little bit on that.
Sure.
That airplane, as it lost hydraulics in the back of the number 2 engine, the tail, the fan split apart and ripped into the hydraulic lines, and thus the aftermath, they redesigned it so they had a backup. But the point being, they lost all their hydraulics, and essentially the only way they could control the airplane was differential power and reduced power as far as their controllability, and also, you know, ascending and descending, because they literally had lost all their elevator
Because the three
and rudder.
hydraulic lines were severed. From what I
Yes,
understand.
just by the poor design at that time. Again, it's enhanced and changed, but at that point, these guys were phenomenal in getting it down. again, 3 engines, basically just down to 2 engines, just scissoring it, and differential power to get it down.
Yeah, there was about a 62% survival rate, so not everybody survived on that.
No,
on
they
that
didn't.
plane. Okay, so very, very important to know how critical, you know, flight controls are for the pilot. So it's a good feeling. Okay, so let's just talk about, you know, I know Rick mentioned a bit ago here about, you know, the different axes. So could you explain that a little bit for
Yes.
aircraft mechanics here?
Well, let's go back to the axis again. I have my handy dandy model one more time up here. And so here we have this airplane coming at you, 777 type, for those curious. And essentially, we're in a 3-dimensional aspect. And again, we have, through the longitudinal axis, we have what we call roll. This roll is controlled by our ailerons and our flight spoilers. And the key is flight spoilers. And then we have what we call the pitch of up, down, and up. And with that said, this is through our elevators in the back. The elevators in the back on the empennage. And through the vertical axis, we have what we call yaw, back and forth. And that is controlled by our rudder. So with those axes involved, and with the controls, there's different inputs. And the inputs obviously come from the cockpit. And that is through the control column. So that's basically it at that point.
Great. Yeah, and we'll follow the trail there from the pilot in the seats with the control column.
Right.
Okay. So yeah, so that gives you an idea on the different axes and the different position or attitude of that plane and different ways that it can go. So you know, it basically here, you know, we have the control surfaces. We have control surfaces that are broken up into 2 categories. We have your primary flight controls and your secondary flight controls. And Rick, can you help us out in explaining, you know, why, and I'm going to mention here in a minute what they are, but what designates those in the primary category versus those in the secondary?
Yes, the primary categories is actually the controllability of the aircraft, if you will, with our ailerons, rudder, and elevator. And the secondary, which is our performance criteria, which we also categorize as for the high lift. Well, that high lift, we want to do at different phases of flight, for example, takeoff and landing, and we want to have steeper approach path. And with that said, we want to be able to slow the aircraft as best as we can with increased lift and basically minimize the drag. But conversely, just to share with you aerodynamics, every time you have an increase in lift, you also conversely increase drag. But there is what we call these high lift devices, which changes the camber surface area of the wing to enhance that.
Okay, great. That's good. Okay, so so that's what those categories are. So think about E or ERA or AIR, AER, because those are the letters that the primary flight controls start with. So what are the components of the primary flight controls? You know, what do we have here? If you're going to take it to be air, that would be AER, by the way. Then you have ailerons. Okay, so that's one component. Number 2 are your elevators. And number 3 is your rudder. So those are your 3 under the category of your primary flight controls. Extremely critical. I mean, those are, like Rick was saying, the controllability of the aircraft. If you don't have a rudder, that's a huge, huge problem, right? When we take away something, imagine what the scenario would be if the plane didn't have a rudder.
Well, it's same as a ship, a boat in the water. You take away the rudder, how's it going to steer? Well, same concept in the airplane. And same aerodynamic principles.
Exactly. So there's that. Okay, so now let's see what's in the secondary category, secondary flight controls. You know, those are going to be your spoilers, right? So we have flight and ground. I know I didn't mention that earlier, but
Right.
I was waiting to let it out of the bag. But that you have flight spoilers, and those flight spoilers, there's a total of 12 spoilers, total of 12. And then how you break that up with flight spoilers, we have
We have 8, 4 on each side there, and essentially the flight spoilers work in conjunction with the ailerons. And we're going to get into the mixing unit, excuse the pun, coming up on that one, but we'll show how those are interfaced. But the flight spoilers are in conjunction with the ailerons on that antistator.
Okay, and then we also have what they call the leading edge devices, which is actually leading edge flaps, leading edge slats.
Right.
Okay. Right.
And just to define, when the difference between flats and slats, and the way I look at this, slats have slots, if you think of it that way, and which are basically gaps, and so it allows energy of the air to go through, which we call in aerodynamics Q. But point being, if you think slats have slots, flaps don't. So that's why they call for example, the double slotted Fowler flap, because it's got 2 slots. That's why they double slotted.
Yep, that's good. Nice memory aids here. And then we do have the trailing edge flaps. So that's part of, again, the secondary flight controls. And that just kind of works in conjunction with the leading edge, right?
Yes, they work, yes. And, and then ironically here, the first 15%, if you will, first 10, 15% is more lift, high lift. The last portion is more drag. So, for example, for takeoff, you'd have the first 10 to 15%, and then after that, you'd have the rest for landing for the steeper approaches, just to share those.
Okay, great. Now, as we continue to talk about the different components, and we're going to cover, like, say, if we're going to talk about elevators, okay, keep in mind that even though you guys, we wouldn't have shared yet about some secondary flight controls, doesn't mean that we're not going to introduce it. So don't let that confuse you. It just means that all these things are working in conjunction with one another. All right. So keep that in mind, because when we're talking about horizontal stabilizer trim control, for example, that's attached to the we got an aileron. It's connected. It's attached.
Yeah.
So they're all working in conjunction.
Absolutely.
Especially when you're looking at the inputs necessary to the PCUs, your power control units. So I'm going to get to that in a little bit, but they're attached. You can't have them separated. You got to have those inputs together so that it can give you, give a pilot that feel force. Right?
If you want to think of it, it's just basically a robot. The airplane itself is the mechanical robot that's working conjunctly. We're just isolating, holding everything else constant, and just looking at the one specific control and how the items are working. And it's basically an A, B, C, D, respectively, down the line through the different systems, ideally hydraulics, which is primary, and electricity that drive them as well. So
exactly, absolutely, yeah, it's good to do that. Remember, hydraulic power. That's why if you took our hydraulics section already, then you'll understand this kind of in an order here that we're doing. Hydraulics is what is powering all of this with flight controls. So we got to look at that too, and we'll go into a little bit about that. But so now you get an idea with what are the components? What are they at all? And then also there's going to be cables. Remember I mentioned that earlier. So the flight control cables. You got the control column in the flight compartment, and then they're attached. Underneath the flight compartment, you've got cables. And those mechanical cables run all the way. So I got to pick up this plane now, okay? But because it just feels so good, is that you got here's the flight compartment, okay? And so underneath that flight compartment, you've got those cables. Remember, I'll explain how many you know that, but you got cables running all the way to the back of the plane, to the tail of the plane. All right. So cables are going to be one of those multi-use systems here. We got cables. And then we also have hydraulic packages. These are going to be your hydraulic modular packages. We got 2. All right, and we got 2 places where hydraulics are coming into play. You've got system A and system B. When we talk about some of these leading edge devices and your trailing edge flaps, we're going to talk a little bit of detail on, understanding, when does hydraulic A come into play, and you got your upper and lower components of input places, like your where it's supplying from one system or another.
We also have our standby as well too, just in case you lose A and B. Our other backup is that standby hydraulics.
Yeah, and think about the order when you think about the priority of flying for a pilot. the priority. You know, you want to make sure those leading edge flaps and slats are working and functioning, right? Your trailing edge kind of takes a back seat. Is that kind of right?
Yeah, you definitely want to have them there for your landing because you want slower landing speeds. And again, how that relates, besides the performance of the distance of your stopping, but you're also concerned about the tire rotation and pressures because the higher speeds, you can blow tires, which will cause detrimental aspects.
Right.
So
exactly.
Slower the better.
Absolutely. So what we're gonna on the cables, we have a lot of different cables. Remember, I was gonna go back to that. So your flight control cables, you've got, kind of think about this, you got 2 for the rudder, 2 for the elevator. You got kind of 4 total, but you got 2 flap control cables, you got your 2 flap follow-up cables, and you've got 6 or 3 pairs for related to the ailerons. Because you got your aileron flight control cables, but you also have body cables and wing cables. Because where are those ailerons located? That's right, they're on the wings. Okay, you got those ailerons on the wings. So, but that's those 6 there. Then you've got 4 other cables, or again 2 and 2. But you got 2 speed brake control cables, and you also have your spoiler brakes. So you got your spoiler cables. So you got 2 spoiler cables, and then we have also the stabilizer control, which we're talking about the horizontal stuff.
Right. Now it's interesting if I interject on this here, Anastasia, is with this airplane, the 737, for those of you who had flown the 727 or earlier Boeing products, i.e. the 707, dating myself, I didn't, but point being, they've taken this airplane, essentially the same system design, the same control design, and they put it in the 737, which is a 2-engine, 2-man cockpit. And now, with that said, they've added electronics. So they interface electronics to this to make it the glass airplane, what it is today. But as we do other Gen FAMs, you'll notice that there will be no cables per se. Well, let me backtrack. There are some backup cables on some of the glass airplanes, i.e. the Airbus, but it's just one primary. It's all electronic. But like I said, this is a 727 basically airplane that is formulated into the 737. So keep that in mind for those of you familiar with that 727 or 707 airplane.
Yeah, that's a good point. Very good point to look at that way. And that's why, again, it's the mechanical input that we're going to talk about here and kind of follow this process. But that's how it is. And those cables are coded. You don't have to memorize all these cable codes. Just know that if you see ACB, that's for aileron control bus. And if it has a letter A after it, it's for cable number 1. If it has a B, next, well, that's cable number 2, right? Because I said they're in pairs. They're pairs of cables. So that's just an example. If you see ACBA, ACBB, those are the aileron cables, and that's aileron control bus, like I said. Again, there's the different ones for the wing cables and the body cables, et cetera, et cetera, et cetera. But I won't bore you with all of that. Okay, but also now we got to look at that we have 2 hydraulic packages, and the packages have different things. They've got a compensator package. They've got the shutoff valve. You've got a spoiler shutoff valve as well. You also have a low pressure warning light, because if you guys do any maintenance, you want to make sure about the warning, because pilots are relying on seeing what's on the instrument panel.
Yeah, if I take it on this, Anastasia, again, on the glare shield of the aircraft, you're going to have a master caution, which is that amber. And essentially, that's just letting you know that we got a problem. Where does that problem occur? And Anastasia said all the flight controls are systematically located in the P5, which is up above the captain's upper left. And all of these controls, switches, and annunciator lights are there. So, and when the master caution comes on, you should have conjunction another light, obviously associated with lock, talk, and flight controls. And also, you'd want to double check, triple check, if you will, the gauge itself. And my point on all this, just because you have a light on doesn't mean you have a problem. It could be a faulty circuit, but you want to cross-check, triple check and verify and check.
Right. Okay, and yeah, that's good. So, it's important, again, with these warning lights, like you were saying. But as far as the hydraulic modular packages, like I said before, there are two hydraulic modular packages, and their components, like I just said before, compensator package, and you got those 2 valves, and again, that we're just talking about the low pressure warning switch. We have a warning switch, so that gives you an idea on that. And then just to kind of go a little bit more on the warning lights, we've got a field differential light. Right.
Yes.
Okay, and can you say a little bit about that?
Yeah, just a quick overview of that. The gouge on that is, and it's a foot stomper on this one. And by the way, we're going to go through foot stompers here, and I'll try to do the best I can. I know Anastasia will too. So to answer the question, a 25% differential between A and B, you'll get this light, and it's field differential.
It's at 25%, by the way, because there's going to be that difference, and we'll talk a little bit more when we get to elevator field computer. But there's going to be that differential pressure, and if it hits 25%, difference in those two pressures, then or that metered pressure, then that's when something gets alarmed, right? There's a valve that closes.
Right, and we'll get into that, and. But the light itself will be triggered on with that. And again, you'll get a master caution, and then you'll get the elevator field differential light.
Right. Okay. So that's one. And then you've also when the horizontal stabilizer high-speed trim is not there, then you have what they call the speed trim fail light that will actually come on. Right. And so that's the same thing with the mock trim.
Yes.
If it's not there, then you're going to have that light come on the panel.
Right.
Okay. All right. And then also auto slat. When those are not available either, you're going to have a light come on. So just kind of keep in mind too that with all the components, the flight control components, we talked about we're mentioning the rudder, the elevators, and the ailerons. They each have their own PCU or power control unit. So we're going to get into that here in a little bit, but they have their own thing there.
Can we just go on that PCU?
Yeah, sure.
Since we're on that?
Okay.
Because all the control surfaces do have a PCU, the power control unit, and essentially it is a distribution center of the hydraulics coming in. You're utilizing that hydraulic power to push basically rods, torque tubes, however, to the control surfaces. So I think it as the heart, if you will, for that specific control surface, because all the fluid's coming in and then it's getting redistributed out.
Right, exactly, and metered. Well,
yeah, it's a meter too.
It's a meter deal. Yeah. Okay, and just kind of get an idea. Like right now, if you were going to go to the plane and you wanted to, know where things were, as far as relating to flight control components flight control, like where the control units are. You're going to find them a lot in the forward bulkhead of the main landing gear wheel well. So main landing gear wheel well is where you're going to find some stuff. Now we're going to talk about the locations of these components. Obviously the elevators are attached to the rear, right? We're talking about the rear part of the horizontal, right here, of the horizontal stabilizer. Okay, so back here, right?
Right.
Okay, so we got it there. And then, here, you want to hold the plane?
Yes, I'd like to hold the plane.
Okay, all right, so we can just start naming them off. But of course, the control column, that's going to be up in the cockpit here, the flight compartment. Your elevator forward control quadrants. Of course, your control quadrants are going to be attached to the cables. They're going to be down from the control column. You've got the cables, okay, and they go underneath that flight compartment, and along with those cables attached to that is these control quadrants, and you got your forward and your aft control quadrants. That again, they're powering things.
Right. And
okay. And they run all the way, like I was saying before. They run all the way
from
so
underneath
over
all
here
the way into the forward compartment underneath here.
Okay, so there's that. And then your elevator control cables, obviously, I just told you. And then you have what's the input torque tube. You're going to hear about torque tubes, but you have those elevator torque tubes. And then the input torque tube, which is going to give and send signal to the PCU, is actually attached to the bottom of the elevator torque tubes. That's where they're located. Right. So giving you kind of a feel, an idea for locations. Now, let's kind of move on to the rudder, because that'll be the next thing we get into after we talk about elevators. But the rudder field and centering unit. Now, field and centering unit, I just threw in a new thing for you here. The field and centering unit, what is that? Okay, the field and centering unit just gives the feel force to the pilot. You want to share a little bit more on that?
Get into a little bit of the nuts and bolts about it, or the cam and the roller, if you will. All these elevator feel centering units are the same principle. Now, the point is, you basically have a cam, you got a roller, and there's a spring. And essentially, what you're doing, it's creating a feel for the pilot. And when you put an input in, you're pushing on the spring, and the roller goes with the cam and then swings back when it releases. And that swing back, because of the spring tension, brings it to that centering. That's why it's called a centering. And the feel is because of the resistance when you go against the spring. The concept is the same for each of these components. So when we talk about that elevator feel or feel centering unit, that's basically it.
Right, and that's the whole idea. That's what I was going to mention when you were talking right now. Is about everything kind of coming back to center. Right. We have a lot of centering linkages. Again, it's all its purpose. All these different components' purpose is to center things.
Correct.
Okay, that's the whole objective, to keep the plane in the right attitude, per se. Okay, so that's great. So that's what when we mention the feel and centering unit here, it's giving you, again, the broad stroke and understanding what its purpose is, and then we'll get into detail of all that. But the rudder, let's go back to, the locations of components, because I'm on rudder right now. The feel and centering unit is in the vertical stab, okay, the vertical stabilizer, or the bottom of the torque tube. So it's
back here.
Yeah, we got it back here. That's the rudder there. So, yeah, and then of course the rudder PCU is above the feel and centering unit. The main, you got a mains PCU, and you got your PCU and your feel and centering unit for the rudder, so that one above the other. So there's that, and then of course your ailerons. Plane again here. Ailerons.
For the roll.
Okay, so you got ailerons, right?
At each end, if you will.
Okay, and then the flight spoolers. Can you show roughly that?
And the flight spoolers are along the middle of the top surface of the air wings. Remember, we have 6 total per wing.
And the ground?
Ground?
The ground spoilers?
Well, the ground spoilers are the same, but they're just different panels themselves.
Yeah, and there's like 2 inboard, right,
yes.
and 2 outboard. Or excuse me, 2 inboard, 1 on each side, 1 captain's side, 1 first officer
Correct.
side, and then outboard, same thing, 1 on captain's side, 1 on obviously.
Right.
So just to give you an orientation.
I know it's hard to see on the video, but that's kind of where they are on the upper surface. I know you guys probably know where they are anyway.
Yeah. Welcome to a Gen Fam. This is not school. You guys already been around airplanes long enough, but I know what you guys want. I gotta get that Gen Fam on that resume. So, but we're definitely covering up. It's just refreshing. Some of this stuff is refresher, but we're going through this. So here we go. So that gives you an idea, again, of what's common. Now, just keep in mind, there's an elevator field computer that is unique to the elevators, and so. We'll get into more detail when we come to talking about elevators. So that pretty much, that gives you the broad stroke, giving you the bigger picture to say, wow, what are we going to really get into now? Well, we just mentioned the PCUs, we mentioned field and centering unit, we mentioned the different flight controls and the categories that they're put in. Why are they in the different categories? How does this all have to do with the flight of the airplane and the safe flying of the airplane? So I hope that gives you a better idea on all that. So.
Well, do you want to start hitting it with the elevators?
I'm good, or if you are.
Yeah, let's do it.
Okay. All right, so part 2, or session 2. Session 2, guys, elevators. How many of you guys have actually done some maintenance on elevators?
Well,
it'd be
it's
nice
hard to
to
see
know.
hands out there. I know. Anyway.
Hard to see at this point, but some of you have, some of you haven't. Like we know, no 2 aircraft mechanics are alike. All right, we know that you guys' experience varies, so we're not going to assume everybody knows this. Now, if we lose, if for some reason we're talking about something, and we're expecting you to already know that, seriously, no problem if you really don't know. It's just that we have a separate, separate video instruction, little snippets of video that can hone in on electrical or hone in on, on the aerodynamics, for example, and help you understand a little bit better even though we didn't cover that in the Gen Fam because that's not what we're here for. This is just a familiarization, getting you back to, the basics on mechanics.
Right.
Right.
And the one thing I'd like to add to this too, for those of you from general aviation airplanes, this is the same concept. Use a 172 for example. Cable goes from the yoke back to the elevator or whatever control surface we're talking, but since we're elevator, the only difference here now with air transport aircraft, between that cable to the final control arm, if you will, to move that elevator, we have a lot of different items in there. And that's what we're going to go over, these different items and what is their purpose, and basically go through that. And again, this is a Gen Fam. We're not going to go right down to the nuts and bolts other than going into listing these items and how they work in conjunction to make that control surface move.
Absolutely. Okay, well said. Okay, so now we're on to elevators. Now, with elevators, I know we're talking about pitch.
Yes.
Right? So you want to kind of remind them that pitch again?
So here we are, airplane's flying at you, and we want to go up and we want to go down. How do we do that? It's through these area, the horizontal stab and the elevator. They do work together, and we're going to go into that. Just to share with you on that.
Right. So part of the elevators, because we have two, is what we have called balance panel. We've got 4 balance panels on each elevator. So we got balance panels, but we also have what they call tabs. We've got the tab control too. We got to look at.
Right.
So we got a little extra piece there, 2 pieces in here.
Well, let's expand on that right now. You got the balance tabs versus the other tabs, which they have counterweights in them. Balance tabs, trim tabs. With this elevator, with the flaps up, they move opposite. And on the aerodynamic, it actually helps, and view on the notes, but it's basically a small airfoil, and it's using the Bernoulli principle, if you will, how it helps assist the elevator by moving in the opposite direction. Conversely, with the flaps down, they move together, so it actually adds to it. And then look at the aerodynamics if you want to get into that, the clips, but specifically that's the difference. So the flaps up, they move opposite. The flaps down, they move together. Now the counterweights is that neutral position. They're balanced in there. That's why they call them balanced, because if you go up, again, they move in opposite direction. So when you go back to the release, they come back to the neutral. And just to let you know, a little forward on this one, those elevators always fare with the stabilizer. So anytime that stabilizer moves, the elevators trim with it through the trim tabs.
Right. Okay, so that's good. That gives the purpose of all that. And then, of course, it's attached to we got a horizontal stabilizer.
Correct.
Because it's all working in conjunction with it.
Right.
So,
as we said before, everything works together, but we're just going to isolate it and put it together for you as we go.
Right, exactly. So, well, let's just talk about, or just bring up right now about the input torque tubes.
Okay.
We got input torque tubes that get input into the PCUs. Remember, PCU stands for Power Control Unit. And it's by moving the input pogos. We've got input pogos. If you look at your diagram, we do have a student handout, so please, if you haven't downloaded it already, do look at those diagrams. But you want to explain a little bit more of that?
Yeah, I'll just go into it with that. It goes into that elevator feel mechanism. And then for that elevator field mechanism goes into what we talked about to the PCU, which is that distribution, because based upon the input that I am going into that PCU, it's going to change the amount of control movement. How does that do it? Through the valves, seals, and inside that PCU to redistribute out to the pogos, which push on the actual control surface. So when the elevator moves, that's based upon the end of the result.
Yeah. So that's great. And then just so you know, in case you do have to do anything with the input torque tubes, remember I mentioned before, they're located at the bottom of the elevator torque tubes. Okay, and those are there in the empennage. So we're starting, remember, from the tail of the plane, working our way. Of course, you have a lot of cranks involved. Don't want to get all the different definitions of crank, but anyway, Crank. Okay. So again, you get your input poker cranks, and have other things. I mean, you have to have cranks to move something else, right? We're talking about mechanics.
Right.
So I mean, it's pretty simple, guys. You guys are mechanics. You know what I'm talking about. You're the same mechanism when we talk about rudder, when we talk about ailerons. You've got those things there. Now, we talked about the fuel and centering unit, so you definitely have that with the elevator. Now, and then of course you got control quadrants. Remember that you got the forward control quadrant, you also have an aft, which is underneath the flight compartment. So remember what I said about everything kind of going vertical, and then it's going horizontal. You start with the control column. The captain he's giving command into that control column. So there it is at vertical, and then everything goes down underneath, attached to those cables. And those cables have those control quadrants. Remember saying that before. So just think about that vertical, then horizontal, and that's the process. And it's going into all these different things that we got going on, input torque tubes and field computer and all that. Now, specifically when we're talking about elevators, I know I said I was going to come back to this and mention it, is we do have the elevator field computer. So this elevator field computer is what sends signals to the
What goes down to
field
the field and sensing unit?
we have the field and centering unit.
And essentially, to back up on that, Anastasia, we have a couple pitot tubes. Now, what's a pitot tube?
Yeah.
Basically, it's just something sticking out there in the airstream, taking the dynamic or the ram pressure. Again, we're getting into aerodynamics here. So essentially, if you blow on your hand, you're feeling that pressure. Well, the faster you go, the more pressure. Well, that pressure is transmitted into this computer. And what does the computer do? It says, hey, I need to modulate the control surface.
Right.
So why? Because you don't want to have real abrupt movements. So plus you have a lot of force, so that it adds or deletes the amount of hydraulic fluid. That's essentially what it does.
It meters it.
Meters it, thank you. So it meters this hydraulic fluid to give you more or less depending on the demand.
Right.
And then also
on the airspeed. Airspeed increases.
Also the demand on your actual movement. Everything works conjunction on this, but absolutely.
Yeah.
And the term is metered. Thank you.
And if you see from a diagram, they have ports. You got 3 hydraulic and you have 2 pneumatic ports for that. And again, it's input. It's getting input from, again, one of the things is the pitot tubes and the pitot ports. And
Correct.
so it's getting all that in there to determine these things. Now, what makes up that field computer? All right, you've got a stabilized actuated cam. You have cams everywhere, okay? But you have that. But you also have your what they call a Q diaphragm, okay? And we'll explain how that process is. But I'm just kind of giving you the components right now of the elevator field computer. So you have that. You also have droop springs, because you have springs as you have cams. You got springs, right? Cranks. You guys always have that. I mean, I feel like I'm talking, I don't know, Greek.
This is the nuts and bolts we're talking about.
This is the nuts and bolts. Like there's
items.
Yeah, exactly. So again, if you want to know what makes up the elevator field computer, obviously you got the ports, 3 hydraulic and 2 pneumatic. Gee, that might be a foot stomper. I'm telling you right now, we're gonna, we have practice questions and they're downloadable. You will have them in a downloadable format. And all those practice questions, I'm telling you, pay attention, know them. It's open book. Obviously, I can't see, whether or not you're looking at your notes at home when you take the test, but I'm just letting you know, pay attention to all of that. But this is a foot stomper. 3 hydraulic and 2 pneumatic ports on the elevator field computer. So you have that. You also have, of course, your relief valve. You have to have a relief valve. I mean, you guys are familiar with relief valves. You also have what they call the force balance valve as well. That's actually moves the force. You got a relief valve that's actually moving that force balance valve. But so you have that, and you also have one very important last piece of component here for the elevator field computer, and that would be the differential pressure. Yeah, because why? Because you have identical. It's a dual unit.
Right.
It has identical components. So when I say springs, it's 2 of everything. When I said, the Q diaphragm, like there's 2. So you got 2 going on. But it's just identical. And so the differential pressure switch is actually able to it actually gets closes when that differential pressure between the A and the B, because you have unit A and unit B, hits that 25% difference.
Right.
Okay. So you just got this picture, of the elevator field control or elevator field computer that's unique for, when we're talking about controlling the elevators or having the pilot control the elevators when he needs to.
Right.
Okay, and that all gets sending output signals to the elevator fuel and centering unit, which elevator fuel and centering unit, it sends signals to the PCU, the power control unit.
Correct. Which again goes out to the control surface, the elevator, which also moves the control tabs.
Yes.
So that's
awesome stuff. Elevators, balance panels, the tabs. Okay, your balance panels have little weights on it, and too, just to throw that in there as well. I don't know if we mentioned that, but
right.
They have little weights. But I know we talked about that. The horizontal stabilizer. Did you want to talk a little bit about the trim on horizontal stabilizer?
Yeah, let's just go through that.
Okay.
I'll start in the cockpit. Here we are in the control column, and it is on the left thumb switch, if you will. There's two switches. They have to work together to make the electric transfer to get allowed to move the motor. We got two motors. We got a motor of high speed and low speed, if you just keep it that simple. With the flaps up, it's a lower speed. With the flaps down, it's a higher speed. Kind of simple with that. And essentially what you're moving is that horizontal stabilizer, and you're doing that for a trimming purposes. And what are we talking about trim? Well, you have these pressures that you're fighting on the control column. If you're hand flying, even though initially the autopilot will be taking care of it, but if you're hand flying, you want to alleviate those pressures. So, again, basic aerodynamics, you want to fare that trim switch, moving the stabilizer, so you relieve that pressure. With the autopilot engaged, it does it automatically, but it's the same concept. And remember what I said is when I do and trim that stabilizer, the elevator fares with that as well, with the help of remember the kind of tabs? It's a balance tab. And basically that moves in opposite direction when the flaps are up. So we have those three working together. Now, again, in the cockpit standpoint, there's a green band. It's on that rolled disc, if you will, and you want to make sure that for takeoff it's in that green band. If not, there's a horn that comes on. It's an obnoxious little horn, and it has to be obnoxious because when you're doing it, you want to say, I have a problem.
Right.
What is that problem? That we don't want to stop that noise. So obviously it brings your attention. Essentially that's it for that.
Yeah, no, that's good. But I mean, we're talking about, again, trim is important, in relation to what we're talking about with elevators. So, okay, so anything you want to with the elevator
just
section?
The stabilizer itself, just give a quick view, because when you're moving that, there's a jack screw in there.
That's right.
And it's, again, the cable's moving the jack screw, which is around a spindle, if you will, and it goes back and forth.
You got a gimbal in there too.
Yes.
And different things.
Following along in the diagrams that you have, you'll be able to see how those are associated. Mm-hmm. And if you want to do some research on that to see the importance when you guys are out there, anytime you have wear on that jack screw, and that's one thing specifically for the different type of high T-tail aircraft. We've had an accident in Alaska. It busted off. Yep. They fixed, again, after the accidents, hindsight's 20/20. But the point I'm getting at, you guys out there, got to keep those lubed, and you have op specs as far as wear and tear. Cannot overemphasize. Be very thorough on that. Trust me, from a pilot standpoint, we trust you. We need you to be thorough. I think I said enough there, Anastasia.
Yes, okay, and with that, we're going to come back later. We're going to take a break right now, but we will come up and later with talking about the rudder and everything related to that particular component.